whole purpose of this session is to sort of try and do a deeper dive into the risk assessment requirements within the CRA. So what's on the slide here are my definitions. So the standards have not been published that we talked about earlier in the talk, which will help to give us a standardized vocabulary for many of the elements within the CRA. But if we look to existing standards, I think for me, when I discuss risk with people, and if anybody's got a different view, as we said, we'd like this to be an interactive session. So either raise your hand, type something in the chat, or help to add. But it's useful to have a definition of risk. And in ISO 31000, which is an operational risk management standard, reflected in 27005, they define risk as the effect of uncertainty on objectives. So when we think about risk, we want to do something in the future, or we want something to happen in the future. And risks are all about what are the type of things that could make that not happen. So a level of uncertainty. So my objective may be to cross the road safely, but there's a level of uncertainty, particularly if I close my eyes or I'm crossing when the man is red, or any of those other factors. But my objective is to get across safely, and there's some level of uncertainty about whether that's going to happen or not. And often we think about risks by considering the event that triggers the risk. So risk on its own is maybe a bit theoretical, but often risks are triggered by an event. So the risk of, or the objective to cross the road safely could be stopped by the event of being knocked over. So that's the event that triggers the risk. And then we try and understand the level of risk by measuring the impact and the probability. Some people say likelihood. I think they're a synonym for each other, impact, and I think for me, as a mathematician, probability is a more rigorous statement. But how far off my objective will I be knocked by the risk, and what's the probability of it happening? So is it a 1 in 10 chance, a 1 in 100 chance, or sometimes people talk about it in elapsed time. Will it happen in the next 30 days, 90 days, the next year? So that just gives some context. So when we're thinking about products, it'll be interesting to contextualize this in terms of the CRA. So we've got to think about product risk. And certainly for me, a lot of the industry, because there hasn't been a regulation like the CRA, has been around operational risk rather than product risk. Because when you build a product and you're designing security into the product, you're thinking about how the product may be used in the future. So it's not something happening today. You're trying to envisage how will my product use and what kind of risks will the user of that product come to. So maybe in the context of the CRA, we're talking about the probability of harm, and because it's a cyber regulation, the harm is coming from a cyber threat. It's in the context of the intended use of the product. So if you sell a product to somebody and they use it in a way that it wasn't intended to be used and they come to harm, that's not actually in the context of the CRA. On when we do a webinar on the documentation requirements, some of the output from your risk assessment ends up in the user documentation where you explain the intended use of the product. And then we think about the event that generates the harm and the measure of the impact of the harm. So if I'm using the product as it's intended, could there be an event that means that harm comes to me or to others, and what's the impact of that harm? So that helps us just place risk in the context maybe of the CRA, because it's risk can also be quite a subjective thing as well. So we have to try and ground it in some objectivity. Maybe if we go to the next slide. So the risk assessment process. So the CRA says conduct a risk assessment, and our view is that you want to try and conduct that risk assessment as early in the product planning and product design process as you can, because it's intended to have downstream use as you develop your product. So the first thing is the definition of product. And in our project, we've been spending a lot of time since the start of the year. The project began in January, trying to figure out good ways, good techniques of drawing a boundary around what is the product and then what's not the product. because that's super important, and it's more difficult than it seems, particularly if a product has multiple kind of components that make up the product as well. And also, just to note, and we'll come on to this a bit later, that the CRA does include remote data processing as part of the product and product definition if it's supporting key features within the product. And we see that more and more today, that connected products have this remote data processing part of the product. So drawing that boundary, saying things inside this boundary are the product and things outside this boundary are not the product, but they are also important because they could influence the types of threats that the product may be subjected to. We need to think about the main features of the product. So what is the product meant to do? So if we were thinking about the definition of risk as the effect of uncertainty objectives, well, one of the things you could think about is, well, what type of threats would stop the product from working as it was intended? So how do I disable the product, or what kind of harm could I come to by using the product as it was intended? And then also, where will I be using the product? So what kind of an environment? We're thinking about environments such as home settings, which may be different from corporate settings, which may be different from high risk settings, for example, regulated sectors under NIS2/DORA, but also how hostile is that environment? So is my product intended to be used inside a protected network rather than out on the public internet? So, what's my kind of operating environment? So to think about that, and then what kind of data processing goes on as part of the product? And as I said, is any of that processing remote, not directly tied to the physical product if there is a physical product? And then just thinking about what the stages are of a risk assessment. So quite often, again, this is quite generalized. You go through a risk identification phase. The risk identification is everything we've said, which is trying to think about what are all the risks associated with the product, and then for each risk, then to evaluate it, take it through a process to figure out. So usually that's figuring out the level of impact and thinking about the probability of the triggering event triggering the risk. So often people use sort of sliding scales, sometimes 1 to 3 for impact and probability, or sometimes 1 to 5, and then they plot them out in a two-dimensional kind of grid. So things that have high probability of happening with high levels of harm, much higher levels of risk. Things that have a low probability of happening that produce low levels of harm, much lower levels of risk. And then we come on to I guess a part of this to generate some debate, because there is some difference between operational risk, as we said, and product risk. So treating the risk. So quite often in this context, in a product, we're trying to reduce the risk. That's often the main thing you're trying to do. So you're saying, okay, look, we have a risk here, and unless we do something about it, it's probably too high to be acceptable to the users of the product. So therefore, we're going to mitigate that risk by introducing security controls. So as Razvan said, if you're using a product that's processing, let's say, sensitive personal data, such as financial data or health data, you may say, well, in order to access that data, the username and password doesn't reduce the risk sufficiently, so we'll introduce multi-factor authentication. So we'll require a second factor. So that's maybe a very simple example of risk treatment. So if I just use username and password, maybe that's doesn't produce enough risk reduction, so we introduce the multi-factor authentication. And then, as we were saying, by secure by default, then I have to think as a product manufacturer, okay, so when you turn the product on, how do I enroll you for that multi-factor authentication? That's something that you're going to need to do by default. It can't come later.
And an example that I often like to provide is general purpose computing and a gaming console, especially some years ago, where the threat model is almost completely different from the manufacturer perspective. So in the case of a general purpose computer that you would buy at home, you can obviously play games on it as well. The threat model that you may have in mind is, okay, how can I protect this device from an external threat source? so the computer doesn't get hijacked. While in the case of a game console, for many, many years, the main threat source was the actual buyer, who would try to tamper with the device, who would try to bypass the digital rights management, who had physical access to the device all the time, who would do anything and everything that was possible to install homebrew and so on, which obviously had some serious consequences, as often such gaming consoles, they were subsidized to some degree by the manufacturer because the money was coming from something else. So this element of intended use and the operating environment, how that particular product may be targeted by a threat source, can lead to very, very different strategies in terms of where you'll put your emphasis on the security controls. So this is one. Then going back to an element that you mentioned, and I think that's a key concept and key term that we need to use, is that risk is not something that we can fix. Risk is something that you need to manage. You put controls in place that will target either the likelihood or the potential damage or impact, but risks cannot be just wiped off. You cannot fix them. You need to manage them.
Thanks, Razvan. Yep. And I think that's the whole concept of risk, risk treatment. And Gazis is asking about risk analysis. Yes, I did mention ISO 31000, which is actually an operational risk standard, because we don't actually have a product kind of definition of risk just yet. I thought it fit, but you're right. Risk analysis, in my opinion, is something done in an operational environment. Here, we have full control if you think about it. So when you're operationally, there's levels of uncertainty, but when you're actually building the product, you have full control as to how to build the product. So you can kind of go straight from evaluation to treatment. So you can say, I've evaluated the risk and I'm not happy with it, so therefore I'm going to treat it. I don't need to do some analysis in the middle. That may not be correct. It may be that the standard does introduce that. We'll know sort of this time next year when some of the first horizontal standards come out, which Annex 1 is a big part of kind of the CRA, just in terms of the technical detail listing, the essential requirements. But yeah, we're trying to figure, because we're trying to build a piece of software that supports this, so we're trying to figure our way through what are the actual discrete risk assessment kind of steps. So if you want to be an early adopter customer, I'll ring that bell again and come and help us with that process. That'll be great. The last piece is risk documentation, and I included that because, again, it's a bit different in that some of the output from the risk assessment will need to end up in the user documentation. So in the annexes, there's several parts that deal with user documentation, but just in general, essentially what you'll have to explain to the consumer, the purchaser of your product, through your associated documentation, including the declaration of conformity, will be a high-level description of the types of risks you've considered and what are the security controls that reduce those risks. One of the reasons for that is that if you provide the option to turn a security control off, and you can do that, so you could offer a user the ability to say, I don't wish to do MFA, I'm willing to accept the risks, but you need to have documented that in the documentation, so the user is making an informed decision about, if I turn that control off, what risks am I exposing myself to. So it's not a case that the security controls, when they're turned on by default, need to remain on always, although there'll be certain circumstances where you might think we won't allow the user to turn off a control because it generates too much risk. Great. Can we move to the next slide? Sorry, go ahead, Razvan.
Just one point here, though. So when it comes to documentation, we need to flag that there is something, let's call it a challenge, that will need to be addressed to some degree, because we obviously are all aware of privacy statements and terms of agreement and all sorts of services that we click accept and we just move on. So there needs to be an element there to ensure that the moment when a user receives this documentation, it's delivered in such a way, especially when we are talking about enterprise customers, that they can understand what is it that the manufacturer has actually done in practice in order to address some of let's call them common issues that you would find in a product.
So just delving into the anatomy of a cyber, so trying to make this practical. So in our software, there's a couple of things we're thinking about. One is that threat modeling is a very good way to go about sort of doing the risk assessment as a really supporting piece of that. So I've got a small graph on the right hand side. So we're thinking about graph databases as a way to express a threat model, because they have nodes and relationships between nodes, which is a key part of a threat model. So we intend to sort of bring that into the software. And what that lets us do is to decompose the product into its constituent components. So how deep do you need to go? Well, that's an it depends kind of point, but certainly within the CRA, explicitly it talks about software bills of material. And I guess implicitly it talks about hardware bills of material, in that you need to know what are all the hardware components within in the product. So if we spread these out in a graph, we say, here's a product, I decompose its components, both software and hardware, and I decompose them a bit further. So maybe I'm getting into what are the software libraries. I may have a major hardware component, but it may have subcomponents, sub-processors, memory, firmware, various other pieces. And we have this conceptual model, almost like a digital twin of the product. And one of the things we're considering on multiple fronts or multiple uses is that construct would be machine readable, first of all. So it can be, if it's exported from one piece of software, it can be ingested into another piece of software because it's machine readable. And that there would be some form of standard ontology, which is a high level description of the possibility of the relationships between elements within the graph, so that there's consistency. So the machine readable format will give the structure to the data, and the ontology will give the structure to the relationships. That would mean, for example, if I'm a product manufacturer and I'm producing a component that I sell to another product manufacturer, and they're including my component in their product, I can give them my threat model in a machine readable format, and they can just simply ingest that. That gives them access to what security is in my component, what kind of threats is it looking to address, what kind of risks is it offsetting. So we're trying to design our platform to be part of an ecosystem. And we'll come on to other activities and testing that will produce machine readable kind of format, so that as SMEs, you can use whatever tools you want, and you can move that data around into different tools with different purposes with different service providers, and that it's all interoperable. So we have really, really good examples. And I'm thinking in threat intelligence, for example, through Oasis, Stix and Taxi are two very commonly used things, which mean that you can move CTI or cyber threat intelligence around between different systems and ingest it. And actually, because it's got an ontology on top of it as well, you can actually connect the right things together. Everybody's calling the same thing. So just in terms of the anatomy of the risk assessment and in terms of the threat modeling, so we're thinking about risks and events. We're then thinking about, well, what threats and threat actors can trigger those risks and events. So this is kind of maybe what's slightly different about cyber when it comes to the sort of process of risk assessment, is because there's agency. So usually, not exclusively, but usually it's a deliberate action by a threat or a threat actor to exploit a vulnerability or a weakness in a system. So that's what's happening. It has agency. There is creativity. They can decide to go a different way. If one path is blocked, they can go the other path, which is different from some other maybe more naturally occurring operational risks. And they're looking for that vulnerability or that weakness. So either that's something that's been disclosed or discovered by somebody else or discovered by themselves, and they're looking to exploit that. And then as the product designers, from a security by design and by default, well, we're then thinking about what are the controls, or sometimes they're called countermeasures, to address that vulnerability or weakness. And that's sort of the sort of descending list. So you kind of go risk and event, threat and threat actor, vulnerability, weakness, control, countermeasure, and you can explore them then in the threat model. So you can figure out, well, I place this control or countermeasure in this part of the product to break the attack chain. So the threat actor is going, okay, well, I'll exploit this, and then I'll push that, and then I'll do this, and then I exfiltrate the data. So you can break that chain multiple places. And then that introduces the concept of security by design, by default, but also in depth, which isn't specifically mentioned explicitly in the CRA, but not relying on just one control. So the example we had about the multi-factor authentication, if the sensitive data that we're talking about is stored in the product, let's say it's stored physically, you may also layer up by having encryption at rest, so that if I physically steal the device and I pull the hard disk or the memory module, if I can, out of the device and I put it into another device, that I can't actually read it, it's encrypted. So that's two different weaknesses, maybe one threat actor. So if I can't guess your password and log in, it's got multi-factor, I go, okay, I'll pull the case open and I'll take the data out and I'll achieve my aims kind of that way. So that's kind of our thoughts when we're building our CRA-AI product, is we want to be able to ingest data from other sources, and then we want to be able to actually export it either through APIs, so that can happen through programmable interfaces, or that it can come in flat files, so you export something from
Actually, we are looking for.
Thanks. I hope you found what you're looking for. It's a lyric from a U2 song. So yeah, so and what do we mean a bit by this? So once you've built the model inside the software, one of the things you'll want to do if you've decided we've got this controller or countermeasure is to test the controller countermeasure. So one way to do that is to have a third-party company do some kind of a vulnerability assessment or a penetration test against the platform. So that might happen externally, say, to our software platform, and within our consortium, we have such a company. So we're actively working on exporting the information from our platform into that pen test platform. The tests are conducted, and then what comes back to our platform, was the test successful? Tick, was it green or was it red, or was it amber? And if it's not green, did the retest fix it? So we don't actually really need to know exactly what the test was. We just need to know that the test results were positive from that other provider who holds that deeper data inside their kind of platform. So that's sort of some of the evolving thoughts we have in CRA-AI, and I'll get on to the AI bit as to why this is also important, but I don't know, Razvan, have you anything to add on machine readability or that type of stuff?
Okay. Thank you very much, Connor. Thank you for bringing this topic to the table. It's something that we are very much interested in, and we are also looking into how this can be can become a common practice and a point of reference for the industry. We feel that this element of having statements that are verifiable, where you can actually show, okay, I have placed this particular technical control, and this is the instrument that I've used in order to verify that it works. It would help quite a lot both manufacturers to know that the product they are putting on the market has passed some sort of a security check. It would also add additional assurance to customers, and it would also make, I believe, the life of and this is an assumption that I'm making now, but I would imagine that the market surveillance authority receiving this type of information, ingesting this type of information, could quickly identify whether at least the major elements that relate to essential security requirements have been covered to practical testing by using specific tools, and that you can also showcase what the configuration of those tools that were used was at the moment when the product was released. I think that would bring a lot of added value. And also, as you pointed out, if this sort of ontology would be created and we would have a reference schema for a machine readable format, it would most likely, I would imagine, create an ecosystem of all sorts of entities that could support various parts of this testing process. So maybe some of those tests you can do internally, others you can do using third parties, and it would add an additional layer of assurance to your potential customers. Thank you.
Thanks, Razvan. And yeah, I think kind of that also maybe touches on a slightly different point about sort of the files that you need to actually maintain once the product is placed. So you could be asked for them by the Market Surveillance Authority, and some of that information would be what tests did you conduct to verify that the security controls or the countermeasures in the product were functioning as intended. So the second part kind of to this is sort of the AI part. So in order to support SMEs through this journey, what we intend in the software is that because things can come in a machine readable format, because we can then put them into a graph structure and extract the knowledge and put that into a graph structure, it provides, again, in a programmatic way, the context of the product so that we can actually potentially leverage AI technologies to do some of the work, the analysis, either for helping to define, for example, control tests, or looking at test results and validating if the test results match the original defined control tests, helping with that evidence locker feature that we want, which is putting into that evidence locker that information and kind of time stamping it so that it can be seen historically, what was done and when was it done, and you have all of that kind of available all the way out to helping to write user documentation. So generative aspects of large language models, which is not exclusively AI or the broader category of data science. The state of the art, we think, allows for some of that kind of capability to be embedded in the software itself to support the SME on the journey, because we're very conscious that in the call that we responded to, it did have an emphasis also not just on SME but micro and small. I think it's micro and small SMEs, which means you're a small medium enterprise, but you're a very small medium and enterprise, because some SMEs can be reasonably sizable. So not having direct access internally to cybersecurity expertise, so that the platform can bring some of that capability. But that's only possible, again, if we have ontologies, things are interoperable, things are machine readable. That really, really just helps. So we'll be pushing to sort of create those standards as a community, either through the project or through any other further initiatives to help sort of build that out. So that'll be part of what we do.
We have a question in the chat. I think this is a really, really interesting moment to introduce that difference between operational risk assessment and product risk. So, for example, in this case, going back to what you presented a few slides ago, this is not about looking at the assets. You look at the features. You look at the operational environment where you will deploy the camera. So, for example, one question: is the camera going to be deployed indoors or outdoors? Do we have a microphone or not? Is it going to be used in sensitive environments or not? And then, for example, you would look at a couple of security properties related to confidentiality, integrity, and availability, and you would start reflecting. Okay, so let's imagine that someone would take over the camera, right? So this is confidentiality, and the camera is deployed inside your house. Now, for example, you look at the microphone. Can the microphone be open in any circumstances? Do you have a switch on, switch off type of feature there? Do you need to authenticate to enable that particular feature? If we look at integrity aspects, can the feed be hijacked? Can I stream as an attacker a different set of video besides that being captured by the camera? Is that possible? When it comes to availability, and I think this was correctly covered by Connor, can I turn off the camera if I'm an attacker? Can I hijack the signal? Can I perform any sort of action if, for example, if the feed is being sent over radio and there's no direct cable connection to the device. So there are all these questions that you would normally need to ask yourself and see what type of controls you would put in place in order to keep those features and also security properties of the device based on how you would imagine that a particular customer would be using your product.